Hello everyone. I hope everyone is doing great. In today's video, I'm going to talk about the PWM output of the Arduino. I'm going to start explaining what is a PWM modulation, how useful it is, and finally, we will use the PWM output in a practical example to change the light intensity of an LED, like it is shown on the screen. If you don't know the Tinkercad platform, which is the platform that I'm using for the simulations, then click on the card on the top of the screen to learn more about it. So, let's get started. Okay. The PWM abbreviation stands for pulse width modulation. The PWM output of the Arduino will generate a squared wave or a pulse train similar to the one I am showing here on the screen. This pulse train is a digital signal, which means that it will only assume two values of amplitude, which is 0 volts or 5 volts, corresponding to our low and high levels. This pulse train is periodic, with a period that we are going to call as T. On the PWM modulation, we control the pulse width by defining the percentage of the period in which the pulse is at 5 volts. This percentage is called duty cycle. To control the duty cycle, we are going to use the analog write function. This function has a numeric parameter that ranges from 0 to 255. This means that if the argument is 127, which is half of this range, the duty cycle will be 50%, which means that in one period, the pulse will be 50% of the time on and 50% of the time off. If the argument is 0, the output will always be off. And if the argument is 255, the output will always be on. Which means that the duty cycle will be 100%. So, basically, to set the duty cycle correctly, we just need to use the rule of 3 with the required percentage and the range that corresponds to the parameter of the analog write function. The PWM outputs of the Arduino board varies according to the model of the board. For the Arduino Uno model, the PWM output can be accessed on pins 3, 5, 6, 9, 10, and 11, and the pulse frequency is 980 Hz for pins 5 and 6 and 490 Hz for the other pins. Now, let's go to Tinkercad to test our example. So, here on the breadboard, we have already assembled our circuit. It is a quite simple circuit. It has only an LED and a resistor. The LED is connected on pin 3, which is the PWM output that we are going to use. The cathode of the LED is connected to a resistor, and the resistor is connected on the ground pin. The idea for this example is also quite simple. We are going to use the analog write function to control the LED brightness in 3 stages. In the first stage, the LED will be turned off, which means 0 brightness. In the second stage, the LED will have a low brightness. And in the third stage, the LED will have maximum brightness. Let's go to the programming part. First of all, we have to name our pin, which is going to be the LED pin, and it is connected on pin number 3. In the void setup function, we are going to define the PWM pin as an output. And in our void loop, we are going to develop our code. We are going to use the analog write function. The first parameter is the PWM pin, and the second parameter is the duty cycle value. In this case, we are going to choose 0 initially, which means that the LED is turned off. Let's add a 1-second delay here so that we can have time to see the brightness change on the LED. After that, we are going to increase a little bit the brightness of the LED. And we're going to add another delay. Finally, let's leave the LED with maximum brightness, which means that the duty cycle will be 100%. Let's add one more delay. And that is it. That is the end of our code. The idea here is to initially keep the LED off. Then, after 1 second, the LED brightness increases a little bit, And finally, after another second, the LED brightness is at its maximum. And the process repeats again. Now, let's check this by running the simulation. From the simulation, we can see the brightness of the LED changing. One time it is off, then it is with low brightness, and finally, with high brightness. Off, low, and high. And the process repeats. And that is it, folks. The main idea of the video was simply to show how we program the PWM by using the analog write function. In the next video, I'm going to show you how to use the analog input by using a potentiometer to control the LED brightness. This kind of circuit is also called dimmer. I hope you have enjoyed this video. See you next time.